All right. So a general idea
Okay.
about moles is basically a quantity of a substance. It's like a unit. We commonly measure volumes in centimeter cubes and meter cubes in liters. We measure weight, we measure time. So all of these physical quantities are no are all those quantities that can be measured. They're also known as the qualitative quantities and quantitative quantities. So any quantity that can be measured is basically a quantitative quantity. So moles itself is also a quantitative quantity that can be measured. So how do you measure moles? You measure it in moles. Moles ka unit be its moles. So there's a formula that we use in chemistry to figure out moles. The first basic formula for calculation of moles is mass divided by mr. Mass of a substance is basically in chemistry you use kgs for sorry grams mass and grams for the mass, and mr is the molecular mass of a substance. I hope you're clear with the concepts of what ars and mrs are. Yeah,
Yes.
relative atomic mass and relative molecular mass. Yeah. So mr is basically the mass of a compound. For example, let's say oxygen. So could you tell me the mr of oxygen?
I can solve it by the formula. Like
Hmm. See,
I don't know.
if you look at a single oxygen atom in the periodic table, you'll see the mass of a single oxygen atom is 16, right? And this
Yes.
O2 has two oxygen atoms. So the total mass of this oxygen atom, this compound here, will be 16 plus 16 equals 32. Okay. So the mr of this oxygen is 32. This is what an mr is. This 16 was the AR, relative atomic mass. Relative atomic mass is the mass of a single atom, whereas mr is the mass of a compound here. So let's say if you're asked to find moles of oxygen, and in the question you're given with mass of oxygen that is, for example, 64 grams, okay, and they ask you to find the moles. So you'll simply use the first basic formula, that is mole is equal to mass over mr. You already know the mass, that is 64 grams, and you know the mr. mr kaise pata lagega? You'll go to the periodic table, you'll figure out the ars, you'll do the relevant calculations, and you'll get the appropriate mr that you'll be using for the calculations there. 32 is the mr in case of oxygen. So simply you can manually solve this equation. 31 times 2 is 64. So the moles of oxygen are 2. 2 moles. This was just a basic calculation. So you should know that this value moles will vary depending upon the mass and mr would always be the same, but the mass can change at times. अगर यहाँ 28 128 होता 32 होता तो ये double हो जाता. Okay, so moles can change according to the masses, because if you look at this equation here and if you relate this equation, moles is directly proportional to mass and it's inversely proportional to mr. Moles is directly proportional to mass and moles are inversely proportional to mr. I hope you know how to write these direct inverse relations. Yeah, you have done this in maths.
Yes.
Okay, directly proportional में सिर्फ ये होता है, you write this sign of proportionality, and inversely you write this one, and obviously यहाँ पे constant भी होता है if you convert this into a numerical equation, but we're not going to do that here and you don't need that in chemistry. Just a general relationship to understand how the quantities would vary. If you increase the m, इसका मतलब ये है कि if you increase the mass, you'll also be increasing the moles here. If you increase the moles, you'll be decreasing the mr, because moles and mr are inversely related. This is how the quantities vary. We've done this example here when the mass was 64, the moles were 2, right? And when the mass was 128, the moles were 4. So as the mass increased, the moles also increased, and we just established this relation here. So this was just a basic formula. Now moving on to some more formulas, how you can calculate moles using other physical quantities as well. So there's another formula that you'll study regarding moles. It's number of particles over Avogadro's constant. Avogadro's, could you tell me a value for the Avogadro's constant?
Mm,
Do you remember this?
I, I forgot. I'm not revising it.
All right, no problem. Avogadro's number is basically 6.02 times 10 raised to the power of 23. All right, this is the value. This value never changes, okay? It'll always be the same. 6.02 times 10 raised to the power of 23. You can write it down in your notes as well. I'll suggest you to keep writing things down, okay? As I write things on the board. This whiteboard will also be available for you after the lecture. The recording will be available. But again, writing notes during the class helps you retain information in a great way, okay? So just write things down. Number of particles, okay, how do you solve these questions? You'll be given with certain number of particles and you'll be asked to find the moles. So you know, okay, whenever you're given the number of particles, you need to jump onto the second formula, that is particles over Avogadro's constant. An example of this could be, let's say, the number of particles are 3 times 10 raised to the power of 15 particles of chlorine here. It's an example question. So आप क्या करोगे कि you'll pick up this value 3 times 10 raised to the power of 15 divided by 6.02 times 10 raised to the power of 23. You can use a calculator and you'll get the answer. Okay, whatever the answer will be, that will be your moles. लेकिन again अब याद यह है कि यहाँ पे the first value was 3.0, the second was 6.02. You need to be careful about the decimal place and the significant figures here as well. Your answer should be in the appropriate significant figures as mentioned in the data. If let's say this was the data 3.0 and 6.02, so you're going to follow the significant figures of the data that has the most significant figures or that has the most decimal places. Okay, so first करो imagine कि आपका answer आ रहा है 1.5, so you'll write it as 1.50, right? 2 decimal places, 2 decimal places.
6.02 constant, we will always use this as the Avogadro constant.
Absolutely, yes, this never changes. Okay. Now we've studied 2 formulas, mass over mr, and let's write these formulas together. Mass over mr is equal to particles over Avogadro's constant. The interesting fact is that you can use both of these formulas together as well. This is why I've placed this equality sign here. Okay, if let's say a question gives you, for example, mass कर लेते हैं. If let's say you're given with mass of a compound that is 100 grams, you are given with the particles that are 2.5 times 10 raised to the power of 10, and the compound is, for example, carbon dioxide here, and you're asked to find, अच्छा तो सब कुछ given है, फिर हम एक काम करते हैं, हम इसका MR छोड़ देते हैं, and you're asked to identify the particle, identify the compound. अब now this is a bit complicated case from moles. होगा ये कि you're given with 2 of the important physical quantities here, and you have to find the 4th one because you already know the 3rd quantity, that is Avogadro's constant. It's 6.02 times 10 to the power of 23. Acha, so up in this type of a question, you cannot use a single formula. I mean, if you pick up this first formula, mass over mr, you already know the mass, you don't know the moles, you don't know the mr. देखो mr पता लगेगा तो compound पता लगेगा ना. So in order to identify this compound, you need to find the mr, right? Relative atomic mass. अगर मैं आपको कहूं कि mr is 32, आप फौरन बताओगे कि इसका मतलब है it's an oxygen, right? So yes, if you know the mrs, you can simply guess the compounds as well. So in order to solve this question, you will have to first figure out the mr of the compound, and then you'll look at the periodic table, you'll do some additions and subtractions to get the exact compound. Acha, so if let's say we pick up this first formula, mass over mr is equal to moles, can you use this formula to figure out the mr? By looking at this data given, the two physical quantities here.
No, we don't have the MR value.
We don't really have the MR value, and we also don't have the moles. You cannot figure out MR from this question. Acha. So if let's say we use the second formula, particles over Avogadro's constant, this one here, by using this single formula, can you find out the MR?
Yes.
And how?
No, we can't. Particles.
You do know the particles. Lekin by using this formula, you'll get the moles, right? You won't get the MR.
Yes.
So you cannot use any of these two formulas individually. So what you need to do now is you need to use these formulas together. Now using this combination here will get you the MR. Try karte hain. Let's put the mass here. 100 grams. MR, let's put it X. Particles, 2.5 times 10 to the power of 10. And Avogadro's constant is 6.02 times 10 to the power of 23. Simply cross multiply the values and you'll get the value for X. Can you do this calculation? Yeah. I mean, you don't need to perform it right now, but just by looking at this, would you be able to do this? The value
Yes,
for
I
X.
will.
Perfect. So this value of X will be the MR value. Once you get the MR value, you look at that against the periodic table to figure out the compound set. This is one way to solve this question. All right, moving on. Let's look at another formula. It's all about these formulas, and it's the most straightforward topic in the A-levels chemistry, I must say. If you know these formulas, just the formulas, you'll be able to solve any moles question anytime. Okay, so the trick is to just remember all of these formulas here. Okay, another physical quantity that we calculate here is percentage yield. The formula for percentage yield is actual yield over theoretical yield into 100. So what is actual yield? Actual yield is, okay, imagine you're performing a calculation or an experiment in a laboratory. अब जो आप perform करोगे ना, the actual yield that you'll obtain in a lab will be the, let's say if you're producing a chemical in a lab. So the amount in a lab will be the actual yield. Whereas, let's say if you get the same amount of chemical through a calculation, that is the theoretical yield. Okay. This is the difference between actual and theoretical yields. For example, if I tell you we are producing carbon dioxide in a lab, in an experiment, and carbon dioxide produced in a lab is, let's say, 100 dm cube. This is the volume. And carbon dioxide that you get by calculation, volume of carbon dioxide through calculation is, for example, 1.5. So the one that you get practically is the actual yield, and the one that you get through a calculation is the theoretical yield. In order to find the percentage yields, you divide the actual over theoretical, 100 over 105 times 100, you'll get the answer. Simple. This is the formula. Is this clear?
Yes.
So most of the questions, they won't just tell you, okay, this is the actual yield and this is theoretical yield. The question would be designed in a problem where you might be asked to calculate percentage yield of an experiment performed by a person in a lab, and that person, let's say, obtained XYZ amount of substance in a lab, and then they calculated the amount to be different, calculate percentage yield at the end. So you should know that any amount that's calculated, that's basically obtained in a practical experiment, is actual yield, and any amount that's calculated out of the written data is theoretical yield. You use this formula, actual with theoretical into 100 to get percentage yield. All right. Moving on. Balanced chemical equations. Balanced chemical equations are very important for moles calculations. You know how to balance an equation?
Yes.
Okay. I'm going to give you an example question here. You let me know how to balance it. I'm placing these blanks. So, okay, can you tell me how to balance this here?
Nitrogen is 2 over here, so it needs to be 2 in the product area too.
Okay, if it's 2 here and it's 1 here, so we need to maybe multiply it by 2, right? Okay.
Yes, but hydrogen will be increased.
Exactly.
6. So we will add 6 in over hydrogen in the product.
3, right? Because that is how we're going to
Yes.
get 6. Yeah. So let's add 3 here because I think this is resolved.
Yes.
And okay, what
2
else?
before nitrogen.
2 before nitrogen here.
No, the product.
Other one, 2 and 3. I think this is solved. Yeah, and a 1 here.
Yes.
N2, 3H2, 2H3. Perfect. This is how you balance the equations. Now, once you have a balanced chemical equation, you can use this equation for a lot of other calculations as well. For example, let's say if you're given with, if the question tells you that moles of nitrogen are 1, can you figure out the moles of NH3 by looking at this equation?
No.
You can. You can always establish ratios. Remember, a balanced chemical equation is the most helpful thing in chemistry here. Dekho, you have a 1 here with nitrogen, right? And you have a 2 with NH3. So, and you're asked to figure out the value of moles of NH3 based on the moles of N2. So first of all, understand the quantities that you're dealing with. You're dealing with nitrogen and you're dealing with NH3. Let's write it down. N2 ratio NH3. Clear up till now?
Yes.
Then write down the data that's given. Look at this. 1 moles of N2 and 2 of NH3. The numbers, the coefficients that balance a chemical equation are basically the moles, the theoretical moles. Okay. So 1 and 2. Sab kuch likh liya? What else? The question also tells you that there's 1 mole of N2 here. So we're going to write N1 here. And they're asking you to find moles of NH3 based on this 1 mole. So let's assume it X. Okay. Now, what you're going to do is you'll use this unitary method. Cross multiply. 1x is equal to 2 ones are 2. X की value 2 आ गई. Moles of NH3 are 2 here. Simple. Clear?
Yes.
You can use the same information between hydrogen and NH3 as well. So for example, if the question, okay, we figured out 2 moles of NH3. Now let's figure out the moles of H2 as well. H2 ratio NH3. H2 is 3, NH3 is 2. We know that NH3 ke moles are basically 2, so we're going to write 2 under NH3 here and X under hydrogen. Cross multiplication, 2 times X and 3 times 2, 6 is equal to 2X. Simple division, X is equal to 3. So moles of H2 are 3. This is how you can use a balanced chemical equation. Got it?
Yes.
I'm going to give you a few example questions now regarding the same balancing technique. And you'll be using these ratios to figure out the unknown values here. Okay. And the equations are unbalanced. You need to balance these first. Do you get the questions? That you have the equations.
Yes.
You're first supposed to balance these. I've written a few value of moles. For example, the first one, you see the hydrogen has 3 moles here, and you're asked to find the moles of H2O. You'll be using the same unitary methods, the ratios, and you'll get the moles. So for all of these questions, you're given with one of the moles, and then you're asked to find the other moles. Okay. Sorry, I'll keep the screen sharing on for a while. You can copy these questions down, and you can take maybe 10 to 15 minutes to solve these. Okay.
I'm confused. ये जो हाइड्रोजन के नीचे मोल्स दिए हैं 3, वो अगर इक्वेशन बैलेंस होगी तो फिर जो मोल्स की वैल्यू वो हाइड्रोजन की अगर पहले कोई नंबर लगा उससे मल्टीप्लाई हो जाएगी.
Depends on the ratio. देखो, just a second. Let me stop the recording here.